Hi, my name is Laura and I'm one of the BEMP educators, and I'm here today to talk to you about one of our BEMP lessons called Dabbling data. This is the lesson that goes over one of the three data sets that we collect monthly, and this is the groundwater well dataset. So we'll go over how do we collect this data set, why it's important, and we will also be graphing some of the data that we collect monthly to see how the groundwater depth changes month to month and also year to year, and try to draw some connections between the groundwater level and the surface water. But before we start getting into topic, let's talk really quickly about BEMP and what does it stand for. So BEMP is an acronym, and that means that each letter stands for a word. The B in BEMP stands for bosque. Bosque is in a Spanish word that means forest. Now, it's not any type of forest, it's a forest that is right next to a river, so it's a riparian forest. The next letter in BEMP is the E, and the E stands for ecosystem. An ecosystem is made of living things that are called biotic and non-living things that are called abiotic, and how these living and non-living things interact together to create this ecosystem. The next letter is going to be the M, and the M stands for monitoring. And monitoring is basically looking or observing something around us so you can keep track over time of these changes that you have been seeing. And finally, we have the P. The P stands for program. And that's because we work with a group of people from different backgrounds. We work with different schools, like your school. We also work with governmental agencies and the University of New Mexico, just to name a few. So this is a little bit the summary of our organization, BEMP, and each of these words. But today we will be focusing on the M of monitoring to get into detail about one of the three datasets that we collect monthly. So what do we monitor? We monitor mainly three datasets when we go to the field every month. We monitor precipitation data, litterfall data, and also groundwater data. And we will go over each of these ones in just a second. The first one that we monitor is called precipitation. So we do monitor the precipitation that falls into the bosque. That can be in form of rain, snow, hail. And what we do is we collect it in these objects that we see in here. These are a well-shaped object. It's kind of like a funnel made of plastic. And in one of the sides, it has a tape measure, so you can measure how much water is in that rain gauge. Now we have two different types of rain gauges. One is under the canopy of the trees, and the other one is in the wide open. And that's because we want to see how much rain actually gets collected by the plants that live in the bosque every month, and how much rain it actually reaches the ground. The second data set is the leaf litterfall. And we collect this data set using black tubs like this one here. And basically what we do is collect the leaves that fall on the ground. That helps us understand the biodiversity, so the different type of plants that we have in the bosque, and also the quantity of these leaves that get into each of these tabs every month, to help us understand the health of the bosque. The third data set is the groundwater wells, and they look something like this picture in here. You can see the well sticking out of the ground. This well is made of PVC, and it has slits underground that allow the water to flow into it. We measure that data set by using this instrument. It's called a beeper, which looks exactly like this one. This is made of a tape measure where it has electric cable inside of it, and at the end it has this sensor. How it works is we basically lower the tape measure, as you can see here with the students, all the way down the well with a sensor at the end. And when this sensor reaches the water, it basically closes this electrical circuit and it makes the beeper beep. And that's because water conducts electricity. Today, we will be focusing on this data set for this particular lesson. But let's start from the beginning. What is groundwater? Basically, groundwater is water that is underground. Now, to get a little bit more into detail about that, let's talk a little bit about how it gets there in the first place. So here we have some precipitation that can be in the form of hail or snow or rain. And when the water reaches the ground, it infiltrates underground. And some of the water is absorbed by the plants. And most of the water actually infiltrates all the way down, and it kind of collects into this area where there is sand and rocks. And in between all these spaces, it's filled with water. That's what we call groundwater. So groundwater basically is any water from precipitation that has infiltrated, as we have seen, the soil beyond the surface and collected in empty spaces underground. The space where this water that has been infiltrated from precipitation holds the water, that is called the aquifer. So the aquifer is basically this body of rock and or sediment that holds the groundwater. Now, we have gone a little bit over how do we measure it, but let's use this section of the bosque to try to understand a little bit better how we do that every month. So here we have a house of somebody in Albuquerque that lives right next to the bosque. Here we have a ditch, the levee, which is that pile of dirt where we can bike or walk right along the bosque. Then we have one side of the bosque with the Rio Grande and the other side of the bosque. And here we have one of our groundwater wells. And as you can see, this groundwater well goes pretty deep underground. So this is a PVC tube that goes as deep as about 4 meters. That would be 13 feet down. And to get you an idea of like what is exactly 13 feet, we use that example of a size comparison. This is a Volkswagen bug and it measures about 4 meters or 13 feet. So imagine that we use this Volkswagen bag and we flipped it sideways and we put it right next to our well. So they should measure about the same. Now, why do we have wells that measure 13 feet and not deeper? That's because the roots of the cottonwoods, which are the main plants that are in the bosque, can only reach as far down as 300 centimeters. So this is a way to know if those roots have enough water to survive or not. As we have said, we go every month and we use this beeper, this instrument, to measure the depth of that groundwater by lowering the sensor with a tape measure all the way until it reaches the water table. And with that sound of a beep, we know how far we need to reach down to find water. We do that for every site, and we have a total of 32 active sites along the middle of Rio Grande, starting all the way up north into Santo Domingo Pueblo and going all the way south to Las Cruces, where we have our site called Mesilla. And as you can see, we have a fair amount of sites in the Albuquerque area, all along the Rio Grande, to collect data monthly about precipitation, groundwater, and also plant diversity and abundance. Here's a specific map of one of our sites. This is an example of the Bosque Farms BEMP site, but all the sites look pretty much the same, where you have the levee on one side and the Rio Grande on the other side. The site is in the middle, and it has the 3 collection data sets. We have the tubs, the literful tabs, which is these round circles. Then we have the rain gauges, where we have the open and the canopy rain gauge. And then we have these 5 letters that represent the groundwater wells. We have the east groundwater well, the west, the center, the south, and the north. And these are the ones that we're going to be focusing on today. Now, to give you a better idea of what we actually measure when we talk about the wells, let's imagine here, this is Albuquerque, this is the Rio Grande, and this is a little bit what the bosque would look like. The trees will look a little different, but we have infiltration, so the water that goes underground, and here is one of this, could be the city wells that reaches all the way to the aquifer to pull water out from the aquifer. Now, our wells and our BEMP sites, they are not going to reach as far down. We said that we only reach about 4 meters or 13 feet. So it's basically to know how much water there is underground available to the plants in the bosque. Now, here we also see the aquifer under the water table, which is the space, that body of rock or sediment that collects the water. And here we have the water table, and the water table is understood as this underground boundary between the soil surface and the area where the groundwater saturates the spaces between the sediments and cracks in rock. So above this water table, there's going to be sediment with some spaces in between, some filled by water, some filled by air. And under that layer, All the spaces that are not sediment or rock are going to be filled by water. Now, let's move on to talk about why it's important, the groundwater, and I have here 2 pictures to help you think about it. So why it's important? Let's think about it for a second. Groundwater is important because all the organisms relying in the ecosystem depend on it. Plants depend on it directly, as we showed earlier. That's why we have the wells in our sites reach as far down as 400 meters. That's because the cottonwood roots can only reach a max of 300 meters, and we're going to make sure that we know if these cottonwood roots have enough water to survive. But not only for the plants that live in the ecosystem, us as humans might be using some of that groundwater for drinking. So groundwater is important for all the organisms that live in an ecosystem, including us. So where does this groundwater come from if it's so important? To help you think about that, I'm going to introduce you the water cycle, which you might already know about. So here we have, again, our house in Albuquerque and the ditch, the levee, and the Rio Grande. And we said that our groundwater is water that comes from precipitation. So we can imagine that part of the cycle is going to include precipitation. Now we said this precipitation falls on the ground and infiltrates underground. Now, what happens once this water is underground or on the surface of the ground to go back up into the atmosphere, which would be representing a little bit the number 1 here. So think about what are some of the things that might help this water that is on the ground go back to the atmosphere, and how once in the atmosphere, this water that is kind of floating around is gonna merge together to finally fall down again in the form of precipitation. To help you think about this water cycle and to help you fill out the first part of our handout, I'm going to show you a video to help you think and to maybe even practice this experiment at home to help you think about how the water cycle works. So let's watch it all together.
Have an adult pour a little bit of the hot water into the jar and gently swirl it to warm the sides. Add some blue food coloring to the water and gently swirl it until the water is completely blue. Turn the lid of the jar upside down and rest it on top of the jar. Place several ice cubes in the lid. Have an adult light a match and let it burn for a few seconds. Lift the lid of the jar and hold the lit match above the water. After a few seconds, drop the match into the water and replace the lid. What can you see? I can see a cloud in mine. Can you? How does this happen? Let's take a closer look. Water is made up of squillions of water molecules. When warm, they don't like to be close together. They move apart, changing from liquid to gas, and rise into the atmosphere as water vapor. This is called evaporation. Evaporation is mostly an invisible process, but by adding the smoke from the match, it allows us to see the water droplets forming a cloud. Remember, it's cooler next to the ice, so as the vapor rises and the temperature cools, the water molecules start to stick together and form water droplets which make a cloud. This is called condensation. White fluffy clouds to dark stormy clouds are all made up of squillions of tiny water droplets stuck together. How did your cloud go? Did you get the same results?
Okay, so this video might help us understand a little bit more a couple concepts related to the water cycle. So it has talked about evaporation and condensation. You can add these 2 words as part of our handout. And we also talked about precipitation and infiltration. So here are another 2 that we have already introduced. Now, if we go back to our water cycle, there is a few more that we haven't talked about yet. These are the 5 and 6 points. So think about us as humans or as organisms that are part of this ecosystem, which is the number 5. Here we have a porcupine. How do we release water into the atmosphere? Think about that for a second. That might help you answer what is this process, number 5. And then number 6 is how plants, not animals, but how plants release water into the atmosphere. It's not exactly the same way as the animals do that. Finally, we have the number 7, which is hidden here, and that is talking about how surface water, when it rains or when it snows, how this surface water actually reaches the river or the ditch water. Okay, so think about how this surface water slides down to a bigger pool of water. That might help you answer that question. So this is an example of our worksheet for today. And here's the section where you will be filling each of these processes to help you think about the water cycle and how we get that water underground as part of the water cycle. And we will be sharing the answers at the end of this video. The next question I want to ask you is, do we get the same amount of water throughout the year? And this is kind of related to the water cycle, but also not. So where do we get this water that we have in our river, in the Rio Grande? Maybe you have watched one of our videos that talks about that in the River of Change video. But we know that part of the water that gets into the Rio Grande, a big part of it, comes from the snow melt up in Colorado. So, because we know that we don't get the snow throughout the whole year, but that we only get it in certain parts of the year, we probably can guess that we won't be getting the same amount of water throughout the year. So it's going to be changing from season to season, maybe from month to month. Another tip that can help you answer that is this picture in here. So we also have storms that are in a different season than the snow melt can also affect the water that gets into the river, but also that infiltrates to be part of this groundwater that we'll be discussing today. So think about some of these phenomena that can impact the data that we will be representing later to help you understand how it fluctuates from month to month or even from year to year. One other question that I would like you to start thinking about is, are the river water and the groundwater connected? So we have been presenting how the water gets into the system through the water cycle. We have been talking about some of the phenomena that might impact the amount of water that we get throughout the different seasons into the river, but also underground. So one question you might have at this point is, are these two bodies of water, the river and the groundwater, connected? And this is the main question that we will be investigating today. And here I have a draw of how to represent the type of connection that the river water and the groundwater might have. Are they directly connected? Do they have a difference in time connection? There's no connection at all. That's what we'll be investigating using our data from BEMP, but also using a model to represent potentially how they are functioning together. So here's the first part of our activity. This is an Aquifer Model video made by one of our educators, Shelby. And Shelby will be introducing to us a model that can represent how this connection between the river and the groundwater might be working. So to help you think if they are or they are not connected. What I'm going to ask you to do is watch this video. There's going to be some questions along the video. Try to think about those. And then at the end, we'll summarize the video and move on to using BEMP data to see if this aquifer model actually represents the reality or not.
Hi everyone, my name is Shelby and I'm a BEMP educator here. And I am going to be showing you a little bit about our groundwater in the Bosque. And to do that, I'm going to be using this really simple groundwater model. With this model, it represents our Bosque. So a simple layout of it is very similar. So we have our mountains on one side, so these can be like the Sandia Mountains. On the other side, we have our mesas and our volcanoes. And having those two high points on either side, just like it is in Albuquerque, creates a valley with our river in the middle. So I'm going to zoom you in now so I can show you a little bit more about how our groundwater works. And we're going to be looking down below the rocks here and seeing exactly how our groundwater works. So now that you can see the model a little bit better, we are looking at how our water underground is connected to our water above ground. So in Albuquerque, it usually rains in the summertime, and we call that our monsoon season. That's when we get the most rain here in Albuquerque. And during that time, we get lots of rain all at one time. And having lots of rain all at one time could lead to flash floods. And within those flash floods, we get lots of water coming into our river. And when there's lots of water coming down into our river, that could potentially carry a few things with it. It also doesn't have to be just with flash floods. Any type of storm event where water is running down the mountains and down the valley into our river, stuff could get pushed into it. So what type of things might get pushed into our river as our water moves from the top of the mountains down to our river? So I'm going to pour some water into our model, and I would like you to look at how the model gets filled up. So you can see underground here in the water. So let's see what happens. I'm going to make it. So through that model, you could see how the water started down here at the bottom and slowly filled up, and then it came to the surface here, right in our river. So in Albuquerque, where do we get our water that we use for drinking? The answer to that is actually both our groundwater and our surface water. So we call our groundwater, in the place that we get our groundwater, the aquifer, and that is the layer of rocks and sediment underground that has that water flowing in between it. A lot of people think that an aquifer is just like a big bubble underground of water, but it actually is lots of rocks, lots of sand, and different sediment that the water is actually moving through. So we use a lot of that water that is in the aquifer and underground for our use and drinking. And that means that we have to pump out water. And a lot of these pumps are located around the city, and a lot of them are also in the mountains. So I'm going to pump out some water, and we're going to see what happens to our groundwater level as I do that. Okay, so I pumped some water out of our aquifer and out of our water underground. So what happened to the amount of water in the river? I also want you to think of what would happen if we only pumped water out of our river. How are these two things connected? How are the groundwater and our surface water connected? We saw that there was a reaction when we pulled out water from the aquifer. It did affect our river. So what happens if we pull out water from our river? How does that affect our aquifer? And at BEMP, we also monitor our groundwater. So our groundwater, what we do is we only monitor up to about 12 feet underground. We don't monitor all the way to the aquifer, which is much lower. And that layer of sediment that the water is moving through is much lower than what we do. But there's water moving all through the ground. And that's kind of an easy thing to think about because we have plants in our bosque that need water, and their roots don't go down hundreds of feet. They only go down maybe 20 feet at max. So they need water to be able to grow. And we at BEMP are measuring that water with our groundwater wells. So now we're going to go back to our question that we had talked about earlier, which is what might get pushed into our river when there is a storm event or a flash flood. So I have some other water here, and this water actually has some food coloring in it, so some blue food coloring, so we can see how it moves through the groundwater. If we only get a rain event in the mountains, we can see how it affects our river. So I'm gonna pour some in and we'll see what happens. There we go. So you can see how that blue coloration has saturated into our river. So if it rains up in the mountains, that affects our river as well and the water that's into it. So make sure you're thinking about what pollutants you might see on the sides of the road or just around you and how that might affect our river. All right, that is it for me. Thank you all, and hope you enjoy the rest of the video.
Okay, so now that we have watched Shelby's video about the Aquifer Model, let's summarize really quick what she has been talking about. So she has presented how the water gets into the model in the first place during the monsoon season, and how water falls in form of precipitation, and it makes it all the way either into the Rio Grande, into the river, or it infiltrates, percolates down into our groundwater. She also has been talking about what happens when we pull water from one of these two bodies of water, either the groundwater or the river, and how they change and how they might be connected. And the third is that she has talked about what happens when there is pollution on the surface of the city, either up in the mountains or even down in the valley, and what happens to this pollution when it rains. Does it make it all the way to the river? Does it stay the same place? Does it make it all the way to the groundwater? Are they connected also in terms of pollution? So these are some of the questions that we want to try to answer, not only using this aquifer model, but also using actual BEMP data to understand what is happening. So before we start talking about the BEMP data, I want to remind everybody that there is an activity related to groundwater that you can find on our website, and that it helps you build your own aquifer model to try to understand a little bit more this connection between the river and the groundwater. So if you're interested in creating your own aquifer model, I would recommend you checking out this activity in particular. Otherwise, with the video, we can move on to look at our BEMP data. But before we do that, I want you to think about some predictions that you might try to answer looking at BEMP data. So if you look at our worksheet, there is this section after watching the Aquifer Model video. And what it's asking you to do is to write down your own predictions of how the river water and groundwater might or might not be connected after you have seen the video and you have seen how the model works. So one prediction could be that if you think that the river and the groundwater are connected, then maybe you will see the data change very similarly. So maybe as the water in the river grows up, the groundwater goes up, and if the river flow goes down, the groundwater goes down as well. So they mirror each other. That could be a prediction if you think the groundwater and the river water are connected. You can think of other ones. We'll give you a couple of minutes to think about that, and then we will move on to look at the BEMP data specifically. So now that you have phrased your potential predictions for this model, let's look at actual data to see if your predictions are actually true or not. To do that, we want you to think about answering two main questions around the data. The first question is if you see any patterns in the data over the month, which month you would see changes and why, and what about in different years. So we will be graphing our groundwater data for the different months of the year, but also we'll be comparing this data in different years. So you have data available from 2014 to 2020. So if you're interested in seeing the changes in this groundwater and river water throughout the years, you have several years to do that. Or if you're interested in seeing how these groundwater and river water fluctuate within the same year, you can just focus in 1 year and graph that particular years to see each month what is happening to those two data sets. I would like you to write these questions down so you don't forget it for later. The other question that we might have, that we have been already talking about, is if groundwater and river water are connected and how. And one question that we might have around that is if they are connected, how the pollution will affect both groundwater and river water. So what we're going to do is we're going to write down these questions in our datasheet. So we have a section here that talks about the BEMP data, and it asks you to write down the questions or hypotheses that we want to answer by analyzing our BEMP groundwater and river flow data. So I will give you a couple of minutes to write down these questions, and we'll go back to look at the actual data. Okay, so now that you have written down your questions for today, looking at BEMP's data, I want you to flip your worksheet over because you should have a graph similar to this one on the other side of your worksheet. And that's what we'll be using today to represent our data. We have the site name at the top, so depending on which site you're working on, you will write the name of the site on the top. The year, so you might be focusing on a particular year. You can also write a range of years, but for the graph, I would recommend creating a graph for each year that you will be representing. And then your name, in case you're in the class and you don't want to get your graph mixed up with your other classmates. Next is the tables that you will be using for this exercise, for this graphing exercise. These tables can be found in our website, and basically we have a bunch of information in here. We have a first column that is called site, and this is because we have, as we said, about 32 active sites along the middle of Rio Grande, and you probably will be focusing in one site to know how this data fluctuates from year to year, from month to month. This site has an acronym of VDO that stands for Valle de Oro, that is down south a little bit of Albuquerque. In this case, the table represents data for 2014, and we have the month 1 to 12, so starting in January, which would be the month 1, and ending in December, which would be the month 12. And here we have the well data, so the water underground, how far you have to reach down to find water. And the units are in centimeters, and that's because we use the metric units to represent scientific data usually. If you remember from our site map, we had about 5 different wells per site, but you only see one number in here for each month. And that's because that's the average of these 5 wells per site per month. Finally, we have our river water, and we also have one value per month. And we'll go over in a second what means CFS, which are the units of river flow. Okay, so this is the backside of your worksheet. You're gonna write down the site, the year, and your name. Today, I will represent a few of the different sites that we have data for. So my first example, it's gonna be based in our video site, so the Valle de Oro site. So you can write this down if you're using that as an example. Then we'll have the year. In this case, I will be representing the data in the table that I showed you before, so for 2014. Then we have the axis. So in the x-axis, we have the months, so 1 through 12. As I said, 1 is January all the way to 12, which is December. Then in one of the y-axis, the one that is on the left, we have depth to groundwater. And one thing that's interesting to point out is this arrow in here. So as you can already see, our 0 starts at the top and not at the bottom of our y-axis. And that's because we want to try to represent how, as you lower the beeper, so as you go down from the surface of the bosque down, how far do you have to go to reach the water table? Okay, so we have a picture of the beeper here and a picture of the well, and we want you to imagine that 0 is the ground, the surface ground, and how far do you have to lower the beeper to be able to find water, and it would tell you in which depth would that be. And this data set is going to be measured in centimeters, as we said before. Then we have another y-axis, and that's going to be in our right side, and that is the river flow data. The river flow data is going to be represented in CFS, and that's the unit that usually it's represented river flow. What is CFS, you might wonder? So CFS is an acronym that stands for cubic feet per second. And to help you understand a little bit that unit, it refers to basically how many cubic feet per second pass a certain point. So a cubic feet, it's the size of a basketball, and this unit is trying to represent how many basketballs are passing through a specific point in 1 second. So the first data that we'll be representing in this graph is our depth to groundwater. If you go to your tables that you should find for each of your sites, you're going to go to the column that says wells. And the first number that you find, that is going to be for month 1. So you will go down to month 1, which is January, and look and find the number specifically to the month. So the first number is 159, so it's about here. We will continue to do that going down. So for month of February, which would be month number 2, it's going to be 157, which is representing here. Month number 3, which will be March, it's going to be 166, so about here, and we're going to continue to do that for all the other months. So April is going to be a little bit higher, June, July, August, September, October, November, and December. When you're done representing that data set, the depth through groundwater for that particular site, what you're going to do is you're going to connect the dots for each of these months. That's because we are representing continuous data. That means data that we collect continuously month to month. Now, my next question is, I want you to think, where is the groundwater at? Is it above the line and dots that we have in here, or below? Again, I want you to think, we have the beeper here, we're lowering the beeper down, and beep, it beeps in here. Does that mean that the water is in this side of the graph or in this side of the graph? So if you guessed this side of the graph, you are correct. The next step is going to be to color all this section below my line graph blue to represent the groundwater. Now, as we have already explained a few times, that space under the line, it's not just full of water. It actually looks more something like this. So there's a bunch of rock and sediment, and the space in between this rock and sediment is going to be filled with water. But to simplify it, we're going to just color it blue. So you should be coloring the section below your line graph blue, and the top one we're going to color brown to represent unsaturated ground. The next step is going to be to graph our other dataset, which is going to be the river flow. So in this case, we're going to go back to our table, and it's going to be the last column representing the river flow. And we're going to go back to the month 1, which is January, and it says that it's 596. So in this case, we're going to go back to this corner of the graph where it is January, but now the 596, it's not in this side of the y-axis, but it's in this other side. And as you can see, the axes here are flipped. So now the 0 is not at the top of the graph, but it is at the bottom, like usually you would represent a graph. So you're going to go up all the way until you find the 596, which is about here. And what you're going to do is you're going to basically imagine a line here that goes all the way to the 596. And that's where you're going to draw your data point in January, month 1, but around the 596 in the y-axis. We're going to continue to do that for the following months. So in February, in month 2, we have 557. So again, you go back to this y-axis, you find the 557 more or less. And in month 2, which is February, that's where the data point would go. And so forth, you're going to continue to do that for each of the months. And then you're also going to connect these data points because it's continuous data that we get for each of these months. What we're going to do now is represent another site, not the Valle de Oro site, but another site to see that each site has their particularities depending on the year in terms of groundwater and river flow. So here we have the AOP site, that is an acronym that stands for the Albuquerque Overbank Project. In this case, we're going to represent data for 2017. And here we have, again, we're going to start with the well data. So here we have the dots for the groundwater well data set from BEMP. And here we can see something a little bit different than the data we represented before. So maybe you have noticed that there is a data point in May that actually goes above the 0 line for our graph. And it's represented with a -21. And you can see here how that is represented in our table. So we have the well column, and here we have the -21 that would be representing this value in here. I want you to think for a second, what do you think happened that month that made our groundwater basically go all the way up above the surface? So you probably guessed that there was a flooding event, and you are correct. Basically what happened is that the water wasn't underground anymore, the water was all the way above ground, and even in some cases it can even reach farther up than the well itself. So when we connect our dots in our groundwater wells, it's going to look something like that, and that's to represent the flooding event. We're going to do the same. We're going to color the bottom part of the graph blue to represent the groundwater area, and the top one brown to represent the unsaturated salt above the water table. Next, we're going to represent the river flow, and you can see here that the river flow actually follows a little bit closely than the other graph, the groundwater data, which is interesting and we'll get to in a second. So we're going to continue with AOP, or the Albuquerque Overbank Project, but we're going to represent data for a year after, so for 2018 instead of 2017. And as you can see, we have the groundwater depth in here, very different than the previous year, very flat. And here we have the river flow data, which is also pretty flat in following the groundwater depth data. Next, we will be representing also a year before, so we have represented 2017 and 2018, and we might be curious to know what happened the year before that, so in 2016. And you can see that the data is not as flat, so we have the depth to groundwater that it fluctuates, it changes a little bit more throughout the year. And we're going to do the same, represent the river flow as well, and you can see that it follows pretty closely the depth to groundwater as well. So the next thing that I want you to do is, if you have represented several years for the same site, I want you to put all these graphs together, similarly to what I've done in here. So you would have year 2016, 2017, 2018, all in a row, so you can see in each month for the full year what has been happening. And let's look really closely, what is this site telling us about the groundwater and river water data. So to do that and to start thinking about these results, we can go back to our initial questions. And the first one was, do you see any patterns in the data over the months? So we can choose one of these graphs. You don't need to look for all the years, but we can choose for each year. And what you can see is that the first month stays probably more or less the same, so it keeps increasing, but there is these 3 months, usually is in May, June, and July, sometimes even as early as April, and it goes as far as July or August. And there is an increment in the river flow that also, you can see that in the depth to groundwater. That happens for this year, but if we go to the next year, you can see that it happens a little bit earlier, but there is also an increment starting in February, and it extends as far as July. So this window is a little bit shorter, this one is a little bit open, but there is an increment in the depth to groundwater level and also in the river flow. What you can see is the last year, this difference in the spring months is not as obvious. There is a little bit of an increment in May, but it's not definitely as significant as the other ones. So you can analyze in here that the spring months for the 3 years, there is a little bit of an increment. In this case, it stays pretty much the same. And in the fall months, you can see that there is actually a decrease, both in depth to groundwater, but also in river flow. And you can see that year to year. In some years, it's more significant than others, but there is a little bit of a change. So when you're trying to answer this question, do you see any patterns in the data over the month? You can probably start talking about what happens in the spring, in the fall. When we look over the years, what is happening, you can start guessing that there is this year, in 2016, that we saw a little bit of an increment in the spring months and a little bit of a dip in the fall months. Here, in 2017, we see a big increment, even a flood event during the spring months, and a little bit of a more significant dip in the fall months. And here in 2018, not at all. So what that might say about the years? Well, we can definitely guess that that was a wet year, one of those years where we get a lot of strong events in the spring that may even provoke a flood event. And how in a year like 2018, for this particular site, we can see that probably was a pretty dry year because there wasn't much of a change comparing spring to fall. And in 2016, we would say that probably is an average year because we did see a little bit of an increment in the spring, which is what we would expect after the snow melt and even some precipitation, and how we can see a little bit of a decrease in the winter months, which is what would be expected. The other question that we're trying to answer is, are the river, water, and groundwater connected? So going back to our predictions, if we said that there is a connection between the river and groundwater, we would probably see the data basically mirroring each other. So we would see the river flow data being very closely connected to the groundwater data. And that's basically what we see for most of our years. The river flow follows closely what's happening to the depth to groundwater. So based on that, we would say that yes, that they are connected. And when we think about how they mirror each other, how when there's an increment in the river flow and the amount of water that there is in the river, it directly affects how much water do we see underground. That means that you don't have to go as deep, the roots don't have to go as deep underground to reach the water table, which is good for the plants that live in the bosque. One point that I wanted to make too is we have been comparing data for the AOP site, the Albuquerque Overbank project. But if you remember at the beginning of this video, I used the video, the Valle de Oro site as well. And I'm representing here the data gain to show you that in this case, the river flow does not follow as closely a connection with the groundwater depth. And one of the reasons why this might happen is because this particular site is a little bit farther from the river. And that means that because it's not as close, the connection between the groundwater and the river water is not as strong as it would be in a place like the AOP site, the Albuquerque Overbank project, because this site is way closer to the river. So depending on how close or far the site is from the river, the connection you will see between the river flow and the depth to groundwater will change a little bit, but you can both see when there is an increment in the river flow data. So when there is more water flushing down the river, there's also going to be more water underground. That means that the roots are not going to have to go as deep to reach the water table in comparison to other months where the roots would have to go a lot deeper to be able to reach the water table. So I want you to try to write down some of these conclusions using your worksheet. So after graphing the data, you're going to go back to your questions, the questions that we just presented to you, and try to answer them. We have been talking about that for the example of these two sites that I've been representing, but I want you to do that for the data that you are representing for your particular site. And go back to your initial predictions and try to answer if you were correct or not with your initial predictions. Finally, there was one final question that we were trying to answer, and that is, do you think the pollution from storms will affect both groundwater and river water? And that is because when we looked at the Aquifer Model with Shelby, we did see that when there was some pollution over the surface of the water, it seemed like that pollution was affecting both the river and the groundwater. Now, BEMP has also been collecting some water quality data for both the river and the groundwater. And what we're going to do is show you a little bit what the BEMP data represents to try to understand if there is that connection, if there is that effect when there is a pollution on the surface, if it affects both the groundwater and the river water the same. So here we have the data represented for one of our sites. This is a State Land Office BEMP site. And what we're going to represent is we collect water quality data for a bunch of different parameters, dissolved oxygen, E. coli, turbidity, conductivity, but we haven't gone over any of those. So one good example that summarizes the pollution that we might have in one site is the nitrates and phosphates. Nitrates and phosphates are representing things like dog poop or fertilizers or even trash. So we're going to use that as a proxy to represent pollution. Now, we would have to look more than one parameter to know for sure, but we're going to just represent the data for nutrients to understand how pollution works for river water and groundwater. So we have represented here, we have in the y-axis the different dates from 2014 to 2016. Here we have the units, so we're representing nutrients in milligrams per liter. And we're going to represent the nutrients are made of nitrates and phosphates. And this data is just for the river, so we're looking at the river, not groundwater yet. And what we can see is that the data fluctuates, and there is a peak, an increment in the data in month 11 of this 2015. What we're going to do next is we're going to represent the same data, so for nitrates and phosphates, but instead of being in the river, is going to be the data set for our wells. So here we have in brown the data that we measure for each of our wells in our sites for both nitrates and phosphates, which can be a proxy for nutrients and that can be related to pollution. And here what we see is that when we saw a peak in the nutrients in this particular date, what we see is that a little bit after we see an increment in the same parameters for the wells. So it seems like the groundwater wells follow with a little bit of a delay in time what is happening in the river water in terms of water quality. And we can see the peak in here instead of the month before that we saw in the river. So to answer the question, do you think pollution from stormwater will affect both groundwater and river water? Well, we could say based on this example that probably yes, because we do see that there is some connection. Now we would have to look more closely for all the sites to be able to draw that conclusion. So that's why we say yes to some extent. We started graphing the data set that we have for other sites. So now instead of being the State Land Office, we have the Rio Grande Nature Center. And what you can see is that also here we have just represented nitrate instead of nitrates and phosphates. So here we can see the nitrates in the river shift a fair amount throughout the dates, and that the nitrates for the wells also kind of follow a little bit what is happening into the river. So based on that, we could accept our hypothesis, but we will have to look more into it to be sure of that. Now, I would like you to step back for a second. We're finishing our lesson, and this is a good graph to try to step back and think big picture what is happening and thinking why it's important to learn about groundwater and river water and this connection. So if we go back to the Aquifer Model video, we draw some conclusions that the river water and the groundwater, they are indeed connected. And if you think about how Shelby was pulling water out from the aquifer, how that was affecting the river water levels, and the other way around, how when we pull water from the river, how that might be impacting the groundwater levels. This is important because we all depend on this water. We all need water to survive, and knowing how these two are connected, how river water and groundwater are connecting, and knowing what happens when we pull water from one water pool or the other might be impacting the ecosystem as a whole, not only the plants that live in the bosque that rely on that water, like the cottonwoods, and how it's important for them to have enough water underground so their roots can reach the water table. But also for us as humans that live in Albuquerque, we get our drinking water partially from the river and also from the groundwater. So knowing that when we pull water from one of these two sources, we are also impacting that connection and the water that is available to other organisms in the bosque. So let's think about all those things and all those connections when you look at your data specifically. We also talked about how pollution moves from one to the other. So if there is indeed a connection between river water and groundwater, maybe when there is pollution after storm events, this ends up affecting both of these pools of water. And that can be problematic if we're using that water for drinking as humans or for the plants and animals that live in the bosque. So how you can help with that, you might be thinking? Well, as a steward of the bosque, maybe you're already doing things to help with that. So I would like you to use a couple of minutes to think about that, to think about what are you already doing yourself or with your family community to help with that, to help reduce the amount of water that we draw out of the ecosystem, either throughout the aquifer or throughout the river, and also how you can help reduce that pollution that gets there in the first place. And if you are not doing anything already, or you think that you could do more, here are a few tips of things that you can do individually on your own or as part of a community to help with that. One of them is to be more mindful with the water usage. Either you can take shorter showers, turning the faucet off, or things like that. You can also pick up trash and dog waste because, as you have seen, the pollution that is on the surface can reach both the river and the groundwater, and that is ultimately the water that we use for drinking. So reducing the amount of pollution before it gets to the water, it would be a good way to help. And also things like write an elected official. So you can communicate your worries, your concerns to different elected officials, either the city, the state, or at a national level. As a community, you can also do things. So you can attend to public hearings, you can go to demonstrations related to this topic or any organized efforts. And if you have the age to vote, you can also vote a political party that defends your values. These are some of the things that you can do as a steward to help with this, but there is many more that probably haven't listed in here and that you are already doing by yourself or as part of your community. So please make sure to share those with us. And with that, I want to say thank you for being here with me today. I hope that now you have a clear understanding of how river water and groundwater are connected and how you can use BEMP datasets to graph and understand how the ecosystem of the bosque works and how you can help improve the health of the bosque for the future generations. Finally, here we have the answers for the water cycle diagram in case you need to correct what you had in your worksheet. Thank you for being with me today, and I hope to see you very soon. Bye.